I'm really happy to have her here. So please give a warm welcome and an applause to Eileen Uchitelle for the keynote.
Oh, is that working? Cool. All right. No, this is not. Wake up. Oh, back. Okay. Moin. Yes, got that right? Okay. I'm excited to be here in Hamburg and be your opening keynote for this year. It's my first time in the city, and you all have a very cute and lovely city. I walked around a lot yesterday. Before we get started, I want to thank the organizers for inviting me to speak today, and thank you for everybody for coming into Hamburg to see everybody speak. This is my first Unconf, so it's interesting that we're all voting on talks and like nobody knows if they're speaking yet, except for me. So, Eileen Uchitelle, you can find me anywhere online at Eileen Codes. Well, actually, mostly on Twitter. I'm not going to call it its new name. It's always going to be Twitter. I work at Shopify as a senior staff software engineer on the Ruby and Rails infrastructure team. For years, Shopify has been heavily investing in Ruby and Rails, and I'm proud to work somewhere that cares so much about our community. I've been contributing to Rails since 2014, and I've been a member of the Rails core team since 2017. The core team is responsible for the future of the Rails framework, and we work together to plan new features and releases. When you've been working on Rails for as long as I have, you start to take for granted how the framework is designed and built. From the outside, Rails seems like a big black box full of secrets only a few know. It's difficult to find your way around the codebase through the maze of gems. It often feels like you're lost without a map. While Rails might look like a mess from the outside, and apparently a lot of you don't like Active Record, it's actually a deliberate, complex, and beautiful framework. It's not designed to be perfect or solve for every use case. Of course, it has flaws like any other framework. But the premise of Rails is to provide a more complete experience compared to other ecosystems. Rails was built to empower developers and unlock our productivity. Today, we're going to explore the magic of Rails. We'll look at the philosophy behind the framework as well as the overall structure of the components. We'll explore some of the common patterns Rails uses to build agnostic and beautiful interfaces, and the techniques it implements to hide complexity so you can focus on building your application. By the end of this talk, you'll be more confident, at least, maybe not totally confident, navigating the Rails codebase and better understand the patterns that it uses to create the framework we all know and love. But Rails is so much more than its design and architecture. We'll also dive into why the community is so important to the long-term success of Rails. So what is Rails? When I ask this question, I'm not asking what the technical definition of Rails is, but rather what makes Rails magic, or seem like magic? What are the driving principles behind its design? What sets Rails apart from other frameworks? Rails is modular but not fractured. While the framework is a set of components, we should be careful not to confuse modularity with lacking cohesion. In the early days, Rails was tightly coupled, and it was difficult to use one component without the rest of the framework. When Merb and Rails merged in 2008, it changed the architecture of the Rails framework, and from that day forward, we had built-in modularity and clear lines of responsibility between gems. Today, we continue to maintain strict rules for each gem and what other components they are allowed to depend on. For example, active model only depends on active support, and we will not accept any changes that break that contract and add new dependencies. We want developers to be able to choose between using all of Rails or just what they need. This empowers Sinatra users or Hanami users to add active record in if they desire, or active support, without forcing them to use the entire framework. Rails is designed to have agnostic interfaces. While the framework provides a set of defaults for applications, we don't require that you use the tools that we've built in support for. We accomplish this by building interfaces that are agnostic to the tool that's being used. If you don't like Minitest, you can use RSpec without too much effort. If your application requires SQL Server instead of one of the supported databases, you only need to add the gem and update your database configuration. Active Record will do the rest. We've implemented similar interfaces for filed upload services in Active Storage and job queues in Active Job. These agnostic interfaces require that external gems work with our provided APIs, but the upside is that it empowers you to make decisions about your application. And the best part is you can change your mind mid-development without rewriting all of your existing code. The Rails framework is unique in that a lot of its functionality has been directly extracted from existing production applications. The very first iteration of the framework came from Basecamp Classic at 37 signals. Since then, we've upstreamed multiple database behavior from GitHub, sharding functionality was influenced by Shopify's monolith, and many other features have been upstreamed from our applications. Because we build and design Rails based on the real needs of real production applications, we can ensure that new features in the framework are stable, resilient, and performant. We test out APIs in our applications and see how they look and feel before they become a permanent part of the framework. This is especially important because once a feature is released, it can't be removed or changed without deprecation. We want to avoid unnecessary churn or an API that doesn't feel quite right. Extracting functionality that we've proven out in our applications is a great way to build reliable and solid APIs. There's one thing that's hard to deny, and that's that Rails has aesthetic taste. You may not love the aesthetic, but it's easy to see that Rails aims to create beautiful, simple, and self-documenting APIs. The core team spends a lot of time debating the interfaces that applications will consume. We will endlessly discuss the right words and how to use them, not because we love bike shedding, but because we want features to look and feel like they've always belonged in Rails. The framework's interfaces are not accidental. They are deliberate and focused on look and feel. You might be wondering, though, if Rails cares so much about aesthetics, why is the code base so difficult to navigate? Why is it easy to get lost in the framework internals if Rails cares so much about your experience? And this is because Rails cares more about your application than it does about its own internals. The framework will gladly take on complexity and ugly code so that you don't have to. To build your application, you don't need to know how to parse the database YAML or how to connect those databases, how to talk to WebSockets, how to implement a test harness, or how to build an image uploader. Why should you need to write the same boilerplate functionality for every application you build? Why should you even need to think about what the MySQL command for creating a database table is when all you want to do is get up and running for your future customers? Rails will handle all of this and more for you so that you can focus on building your application. The way Rails hides complexity is a feature, not a bug. Rails is, of course, not simply defined by these 5 tenets, but they represent the motivations and goals of the core team and how we think about the framework. The architecture of Rails didn't happen by accident. The way it's built is a deliberate choice to abandon certain ways of doing things in order to optimize for the human experience of building web applications. Because of everything Rails tries to do for you, the code base can be incredibly difficult to navigate. There is no one person on the core team who understands how every part of Rails works, but because we all understand the patterns that govern development, we can usually figure out how any part of the framework is implemented. Once you understand how it's designed and architected, finding your way around becomes a lot easier. Rails is made up of 12 components seen here. The first version of Rails had only 4 gems: Active Record, Action Mailer, Action Pack, and Rail Ties. Out of the 12 current components, 4 are original, 3 are extracted from those original 4, and 5 are additions. The decision to add new components doesn't happen often. We want to be mindful about what does and does not end up in the framework, because anything that goes in needs to be maintained by the core team. There's only 12 of us, and while that sounds like we have 1 person per component, it doesn't work out that way. Each one of us on the core team has an area of expertise, but none of us are the owner of any particular component. One of the things that comes up often when talking about how Rails is designed is what is the significance of the naming convention? Why are some gems prefixed with active and others with action? And you might be wondering why Rail Ties doesn't follow the pattern. The libraries that are prefixed with active are generally ones that support back-end behavior. These include Active Record, Active Support, Active Model, Active Job, and Active Storage. They are all responsible for doing things behind the scenes. The naming convention was originally influenced by the Active Record pattern, which Active Record is, of course, named after. It made sense to use the same prefix for those other backend components. DHH wanted the gems to follow a similar naming convention, so action followed active to indicate parts of the framework that are user-facing behavior where a user does an action. So those are action mailer, action pack, action view, action cable, action text, and action mailbox. The rule for how to name a framework is sometimes framework component is sometimes a little bit blurry. You could argue that action cable isn't nearly as user-facing as the diagram implies, but hardly any name for something is perfect. Lastly, the piece that ties all of the components together is rail ties. A railroad tie is one of the cross braces that supports a metal rail on a railroad track, so it makes sense that rail ties does not follow the action and active naming convention since it's the part that ties everything together. Rail ties defines the rail's constant and is your entry point into any application from the framework. While rail ties is the core of the framework, none of the gems and rails depend on it. This is what allows you to use parts of rails that you want without committing to using the entire framework. The modularity of rails is a conscious choice to give you the freedom to use only what you need. Rails implements a bunch of common patterns and techniques to build the interfaces and APIs that applications will consume. Ruby on Rails makes heavy use of factory patterns, inheritance, metaprogramming, and uses a series of hooks and callbacks to control the load order of components and their configuration. Navigating Rails code can be difficult because it's taking on a lot of complexity in order to provide consistent interfaces and simple APIs. However, the techniques that Rails uses enables the framework to provide an application development experience unmatched by any other framework. Let's first look at how components interact with rail ties to get a better sense of the role it plays in the initialization process and how it ties the framework's components together. The entry point from an application to a component is rail ties. Any gem that needs to hook into the initialization process will contain a file named railtie.rb. This is where we define the load hooks for the framework, which apply application configuration and settings. In addition, the config environments and config initializers are how your application hooks into rail ties and the components. Not every component implements a rail tie. It depends on whether the gem needs to extend or modify the initialization process. External gems that need to interact with initialization and configuration will also provide their own rail ties. Think of it as an API for hooking into Rails while it's booting. The rail tie functionality in a component can only be used within a Rails application. If you're using Active Record with Sinatra, for example, you're going to need to apply configuration that came from Active Record yourself. Some of the things that just work out of the box with Rails needs to be manually implemented when using components outside of the framework. Let's look at an example of how rail ties work. So when you boot your Rails application, rail ties will register the load hooks for each component from the defined initializers. Then it will wait until each component is loaded. And then once they are done loading, the hooks that were registered before the application was booted will then be run. In general, rail tie initializers are run in the order they are defined. Therefore, anything in your application will always run after Rails initializers. This functionality makes boot time faster by enabling lazy loading of Rails components. Let's take a look at some code to see how this works in practice. So if you look at the railtie.rb file in any of the components, you'll see that they define a bunch of initializer blocks that look something like this. If we take a look at the method in Rails, we can see the initializer takes two arguments, a name and an options hash. The name is simply an identifier, and the only options that are accepted are before and after, which can be used to control the order the initializers are run in. In most cases, we don't set any options because we want the initializers to run as they are defined. However, the before and after options are useful if we want one component's initializer to depend on another component's initializer. Initializers take a block which returns the application that we're working on. This can be used to interact with the methods defined on the application object or access the config object as seen here. Within these initializer blocks, you'll often see an onload hook that tells Rails to register an action but wait until a specific component is loaded to call the code inside the initializer. Onload hooks enable the ability to apply application configuration lazily by registering a hook that will be called when the library is loaded. The initializers are often used to set required functionality as an application boots. For example, if you've ever used Active Record outside of Rails, you will need to call establish connection. However, in a Rails application, the connection is already established for you. So where does this initial connection happen? In an initializer, of course. So if we look at the railtie.rb for Active Record, we can find the initializer that is responsible for establishing connections to Active Record base when we boot our application. The name of the initializer is ActiveRecord.InitializeDatabase. Because we have an onLoad hook, this initializer will not run until the ActiveRecord component has finished loading. When this code is run, it will first find the database YAML file from the application's path and parse the ERB. It will then pass the result to ActiveRecord base configuration setter. This turns the YAML into database configuration objects. Once the database configurations are set, establish connection is called, and that's it. That's how Rails sets configurations and sets up our initial connection. Establishing the initial connection for you is just one of the many things that Rails does when you boot your application. Initializers also let us avoid calling components if they aren't included in a Rails application. In this initializer, we can see that ActiveRecord will include the controller runtime module only if action controller is loaded, and will include the job time module only if active job is loaded. If an application doesn't have action controller or active job, then these modules will never be included. This avoids requiring applications depend on any of these components. While these are all really simple examples that fit on my slides, because I could put more complex ones that do not fit, there are plenty of other initializers that you can find in the Rails code base. So the next time you're curious what Rails is doing when you boot your app, pop open one of the railtie.rb files to find out. The important thing to take away from this is that rail ties is the core of the framework, and it's what ties your application to each component. Most of the major components of Rails will implement a rail tie to apply configuration and set up the application during the initialization process. Without rail tie initializers, we would have to do a lot more manual setup ourselves in our applications. The role of rail ties is to handle configuration and initialization for you, so you don't have to think about any of these moving parts. Rails uses the initializers with onLoad hooks to control the load order and ensure that hooks are run at the right time. It prevents a component from being loaded too early and is also one of the ways we ensure Rails configuration doesn't override your application configuration. Finally, rail ties enables components to interact with other components without making them dependencies. Because the rail tie waits until a component is loaded to call its code, we can define behavior for when a particular gem is available in an application. For example, as we saw earlier, ActiveRecord will only include the job runtime module if active job is loaded. If it's never loaded, we don't create an unnecessary dependency between the two libraries. While we only looked at a couple examples, this just barely scratches the surface of the power of load hooks. The next time you're wondering where configuration is coming from, look in the components rail ties for the answer. Earlier, we talked about how Rails provides agnostic interfaces, which enables you to swap out default functionality as long as external tools implement the interface that Rails provides. One example of this is how the ActiveRecord database adapters are implemented. By default, Rails provides support for 4 database adapters: SQLite 3, Postgres, MySQL 2, and Trilogy. If you haven't heard of Trilogy, it's a new adapter for MySQL that was originally built at GitHub and then open sourced, and then we put it in Rails. So it's available in the Rails 7.1 release and every release after that. If you look at ActiveRecord's code base, you'll notice that we never ever call ISA on the database connections adapter. This is because adapters are implemented in such a way that the interface is agnostic to the database client that you're using in your application. We achieve this by building an abstract adapter class that implements the API. Then all concrete adapters inherit from the abstract adapter. The way this works is the abstract adapter defines the interface. You should never interact with the abstract adapter directly in your application. You should only ever use a concrete adapter. Each concrete adapter then inherits from the abstract adapter and therefore automatically defines the same interface through inheritance. The default behavior for each method is stored on the abstract class since that defines the interface. Concrete adapters, including the ones external to Rails, are required to inherit from the abstract adapter to get the shared interface and implement the same public APIs. The pattern that we use to create agnostic interfaces means that in Rails, we can have a method like supports foreign keys, and we don't need to do an ISA check on all the adapters because they all answer the same methods. If a concrete adapter wants different behavior from the default, it can just re-implement that changed behavior. So as an example, here we have supports foreign keys on the abstract adapter. We can see that by default, it's set to false. If we look at Postgres, this method is implemented to return true. MySQL 2, Trilogy, and SQLite 3 gems adapters also define this method. The abstract adapter sets it to false rather than true because we don't know if external adapters that we don't control will be able to support foreign keys. This creates an interface where foreign key support is opt-in for any database adapter for Rails. Another example of a place where we use a similar pattern to create agnostic interfaces is active storage. Active storage implements this pattern slightly differently from active record. Here we have a class called service, which is equivalent to our abstract adapter. It is our abstract class that defines the interface. But instead of defining default behavior in the abstract service, it just raises a not implemented error. This signals to external gems implementing an active storage adapter that they must implement this method for the service to work with Rails. If we open up the Google Cloud Storage service, we can see the implementation for the delete functionality. Every available service for active storage will implement this method in the concrete services where the abstract service raises a not implemented error. The agnostic interfaces allows Rails to call the delete method on the service object without having to check what service we're using. Whatever service we have set in our configuration, Rails will call these methods and our service will answer. Using this pattern reduces code complexity and makes it super clear what the interface is. We can guarantee that Rails will just work as long as the concrete service classes inherit from the abstract service and implement the specific behavior for each method. To recap, Rails uses an abstract class and inheritance in order to implement an agnostic and consistent interface for the services that we support. It also provides an easy way for library authors to build their own service or adapter. Rails implements an abstract class, which all concrete classes inherit from. The abstract class is responsible for defining the interface, and the concrete classes are responsible for changing the behavior by defining those methods. You will see this pattern anywhere in the Rails codebase that we need to implement a pluggable interface. One of the benefits of this pattern is it simplifies the Rails codebase by avoiding calling ISA everywhere. We can assume that any call on any adapter or service will implement the interface that's defined. Anytime a method is called, Rails already knows how to respond. This also avoids undefined method errors for any external adapter or service. They can fall back to the default behavior or get a not implemented error to indicate that they need to define that method. In addition to simplifying Rails code, the patterns that we use to create agnostic interfaces make it easy for applications to swap out adapters. If you start your application with SQLite 3, you can easily switch to MySQL 2 by updating the gem and the database configuration. This applies to active storage service as well. If you don't like Google Cloud, you can just switch by adding a gem and updating the storage config. Everything else just works unless you're doing something that you're not supposed to. And we can't help you. These interfaces allow us to provide a set of defaults without forcing you to be locked into what we provide if you want to use something else. Lastly, implementing a default set of interfaces that any external provider can hook into lowers the maintenance burden for the core team. We don't need to know how every available service that exists works. Instead, we provide the ones that we're comfortable maintaining. Rails is a big framework run by a small team, so we need to ensure that we're not taking on more of a maintenance burden than we are able to support. Agnostic interfaces that implement a stable API for external gems allows us to avoid supporting an infinite number of providers while not locking you into the default options. In addition to the patterns that we've looked at, Rails makes heavy use of metaprogramming to achieve simple and beautiful APIs. Because of this, it can sometimes be difficult to find where behavior is defined. A lot of what people think about when they talk about Rails magic is powered by metaprogramming. While it can be difficult to trace code that uses this technique, it's essential to building APIs that are beautiful and hide complexity. There are a lot of examples of metaprogramming in Rails, but today we're only going to look at one simple example of how we use class eval to build the associations getter and setter APIs. So let's say we have two models, post and comment. Post has many comments and comment belongs to post. Pretty simple, right? Have you ever wondered how you're able to call post.comments without defining the method in your model? How does post know about comments method at all? Active record can predict that you're going to add it to your model, so you know there's no way there's a hard-coded comments definition in Rails. Figuring out where this is defined can be pretty difficult if you don't know where to look. When I don't know where something is defined in Rails, I use Ruby's source location method, which will give us a file name and line number of where any method is defined. We can find the definition of comments by calling method on post and passing comments as a symbol to it. This will work for any method defined on post. Then we can call source location, which will output the information that we need. If source location returns nil, it means that the method is defined in a C extension or in C Ruby itself. This tells us that the comments method is defined in association.rb on line 103. So if we open that file, we can see that it points to a method in Active Records Association class named defineReaders. This method takes a mixin and a name. Using the mixin passed in, Rails will call class eval on it. Now, if we don't know how this metaprogramming works, we might assume that the mixin here is the post model class. However, it's actually a dynamic module named post-generated association methods, which is dynamically created when the post model is loaded. This module is where Rails defines the interface for the post model. This is important because the magic behind Rails comes from methods, classes, or modules that are dynamically generated when you boot your applications and your models are loaded. It's not obvious this is how associations work unless you've spent time in the code. Okay, back to defineReaders. So inside the class eval block, a method is defined using the association name. In this case, it would become def comments. Active Record looks up the association from the association cache and then calls the reader method on it. Using metaprogramming here lets Rails provide an API to access comments on post rather than forcing you to implement your own comments method or calling reader in your application. The writer method has a similar looking definition, except for it calls writer and passes a value. You can see that these definitions are almost the same, but each are implementing a different instance method. You'll also notice that class eval is passing a magic file and line variable. This is a feature of Ruby that lets us define the file and line of the metaprogrammed API to make debugging easier. This is what allows source location to work correctly. There are a lot more methods that are dynamically generated when working with associations in Rails, but we can't cover more of them today. My hope is that by showing you how we use metaprogramming to build one beautiful and simple API, that this will feel less magical when you're working with an association. Association accessors are just one example of how we use metaprogramming in Rails to provide your application with beautiful, simple, and clean APIs. Without utilizing this functionality, we would not be able to have methods like post.comments and active record. Metaprogramming makes Rails a lot more complex internally, but the trade-off is that it enables us to hide complexity from your application. The alternative would be running your own queries and defining your own comments getter and setter. That doesn't sound very fun, does it? Rails doesn't want you to have to do any of that work yourself. We want to provide you with sensible, self-documenting, and simple APIs that just work. It's the beauty of Rails and where a lot of the so-called magic comes from. We use metaprogramming techniques throughout the framework like method missing, class eval, instance eval, and define method, generated modules, and much more. Metaprogramming enables us to build interfaces for migrations, generators, and so much more. Many of the features in Rails are built using some level of metaprogramming. While super powerful, this does make Rails internals more difficult to navigate. The trade-off is you get beautiful APIs and you don't have to think about how these methods are generated. Rails just handles it for you. If all of this was new to you, you're not alone. When I first started working on Rails applications, I didn't know anything about how Rails internals worked. I had no idea how Rails is architected, the role that Railties plays, how we use metaprogramming, or how Rails uses common patterns to create agnostic interfaces. I had no appreciation for how Rails is designed and built. In my early days working on the framework, I had no idea what I was doing. I got stuck often, I made mistakes, I got frustrated, but I found learning how Rails internals worked exhilarating. For me, Rails is so much more than just a framework. It gave me a career and a community. Rails isn't just code or the patterns that we looked at today. Rails is greater than the sum of its parts. Rails is inspiring. It brought us convention over configuration to help us eliminate boilerplate code. Rails, along with Django, popularized the MVC framework, MVC pattern. Rails inspired Elixir's Phoenix framework and PHP's Laravel framework. Even if you don't love Rails and think we make weird choices, you can't deny that it didn't influence much of what we know of as modern web development today. Rails is not just inspiring, it's empowering. Rails wants you to be productive, so we swept away all the tedious problems like scaffolding and migrations and database connections so that nothing was in your way. Rails builds agnostic interfaces so that we can provide sensible defaults without locking you into whatever we think is best. We ensure that Rails is modular so that if you don't want to use the whole thing, you're empowered to use just the parts that you like. Do you prefer Sinatra but really want active record? You can do that. Want to write a simple script but really would love datetime helpers from active support? You can do that. There's a reason we have a video of how to build a blog in 15 minutes. Rails does everything it can to empower you to build quickly and efficiently while keeping complexity out of your way. Rails is also imperfect. I spend a lot of time telling you how great I think Rails is and all the things that it does for you, but I'm not going to say it has no flaws. Rails aims to be a framework that meets about 80% of users' needs. Rails doesn't try to do everything under the sun. Instead, it wants to make you just productive enough by giving you most of what you need. Rails is also imperfect because it's 20 years old. It's no longer an unruly teenager. It's a mature and stable framework. But sometimes maturity means imperfection because we can't just change functionality if applications depend on how it works today. Rails is also imperfect because the people working on it are imperfect. We make mistakes, we add features we thought were a good idea at the time, we've broken builds, we've broken apps, we've created security vulnerabilities, but we also fixed them. So that's important. But imperfection is a part of being human. Rails is also the applications we build with it. From small businesses to large enterprises, Rails powers so many of the applications we interact with daily. There are thousands and thousands of applications in the world using this framework, and they are one piece of what makes up Rails. Rails is the team behind it. As a maintainer, my goal is to see the framework evolve and ensure the community of contributors continues to grow. The maintainers are the ones making sure releases happen on a regular cadence, that features get merged. We assist new contributors, answer bug reports, help out in Discord. Without the 12 core team members and 27 other maintainers, we wouldn't have Rails as it is today. In the years since Rails has been open source, over 6,000 people have contributed. Every single person who has made a change to the framework is a part of Rails. And of course, Rails is the community. The community is not just the core team or just the framework. It's all of us. We make the community what it is. Without a community of users and contributors, Rails is just thousands of lines of Ruby code. But we all know that Rails is so much more than the sum of its parts. It's human-centered design, agnostic interfaces, and beautiful APIs that are extracted from applications. It inspires and empowers developers. It's imperfect and flawed. It's the applications we build, it's the team behind it, and it's the community. And maybe it's a little sentimental to say, but I think Rails actually is magic. The role each of us play in development, community, and future are what makes it magical. It's up to all of us to continue building this framework and community so that new people come join us and those who are here stay. Connecting with people is the reason we're all here. It's what makes it all worth it. So I'm grateful to be back at conferences, meeting new folks from the community and seeing old friends. We might have different goals, but we all care about the same thing, Ruby on Rails. So I hope you'll join me in being an active and present part of Rails' future, whether that be through conferences, blog posts, mentoring, or contributing. Let's work together to ensure this framework and this community are something we want to keep coming back to. Thank you.